A programmable logic controller, PLC, is a digital computer used to control and monitor industrial processes, machinery, and equipment. Programmable logic controller are widely used in various industries, including manufacturing, oil and gas, power generation, and transportation, making them a crucial component in modern industrial automation. Components of a programmable logic controller. 1. Central Processing Unit, CPU. The CPU is the brain of the programmable logic controller, executing instructions and controlling the flow of data. 2. Memory. Programmable logic controller have various types of memory, including random access memory, RAM, read access memory, ROM, and electrically erasable programmable read-only memory, EEPROM, which store programs, data, and configuration settings. 3. Input-Output, I/O, modules. I/O modules connect the programmable logic controller to external devices, such as sensors, actuators, and motors. 4. Power supply. The power supply provides the necessary power to the programmable logic controller and its components. Operation of programmable logic controller. 1. Program creation. A program is created using a programming language, such as ladder logic, function block, or structured text. 2. Program download. The program is downloaded to the PLC's memory. 3. Input-Output scanning. The programmable logic controller scans the input-output modules to read input data and update output data. 4. Program execution. The programmable logic controller executes the program, using the input data to make decisions and control the outputs. 5. Monitoring and debugging. The programmable logic controller can be monitored and debugged using software tools, such as programming software or human-machine interfaces, HMIs. Types of programmable logic controllers. 1. Micro-programmable logic controller, small, compact programmable logic controller used for simple control applications. 2. Nano-programmable logic controller, extremely small programmable logic controller used for very simple control applications. 3. Small programmable logic controller, compact programmable logic controller used for medium-sized control applications. 4. Medium programmable logic controller, standard-sized programmable logic controller used for large control applications. 5. Large PLCs, high-performance programmable logic controller used for very large and complex control applications. Programming languages used in programmable logic controllers. 1. Ladder logic, LLL is a graphical programming language that uses symbols and lines to represent logical operations. 2. Function block, FB is a graphical programming language that uses blocks to represent functions and logical operations. 3. Structured text, STST is a textual programming language that uses statements and functions to represent logical operations. 4. Sequential function chart, SFC is a graphical programming language that uses charts to represent sequential operations. Advantages of programmable logic controller. 1. Flexibility. Programmable logic controller can be easily programmed and reprogrammed to adapt to changing process requirements. 2. Reliability. Programmable logic controller are designed to operate in harsh industrial environments and can withstand extreme temperatures, vibrations, and electrical noise. 3. Scalability. Programmable logic controller can be easily expanded or modified to accommodate changes in process requirements. 4. Cost-effective. Programmable logic controller can reduce costs by improving process efficiency, reducing energy consumption, and minimizing downtime. Disadvantages of programmable logic controller. 1. Limited flexibility. Programmable logic controller are designed for specific tasks and may not be easily adaptable to changes in the process or system. 2. Dependence on programming. Programmable logic controller rely on programming to function correctly, which means that errors or bugs in the program can cause system failures. 3. Vulnerability to cyber attacks. Programmable logic controller can be vulnerable to cyber attacks, especially if they are connected to the internet or other networks. 4. Maintenance requirements. Programmable logic controller require regular maintenance to ensure they continue to function correctly, which can be time-consuming and costly. Applications of programmable logic controller. 1. Manufacturing. Programmable logic controller are widely used in manufacturing to control and monitor production processes, such as assembly lines, packaging machines, and material handling systems. 2. Process control. Programmable logic controller are used in process control applications, such as temperature control, flow control, and pressure control. 3. Power generation and distribution. Programmable logic controller are used in power generation and distribution to control and monitor power plants, substations, and transmission lines. 4. Oil and gas. Programmable logic controller are used in the oil and gas industry to control and monitor drilling, production, and processing operations.